Bio 100 is a science class, which makes you think, what is science? Well, science is what very curious people use when they want to learn new things and understand the world. Science is focused on facts, not on opinions. And a lot of people think of science as just a bunch of facts. Got to learn the facts, got to memorize the stuff. Science is that, but it's a lot of other things. It is a method used to reduce uncertainty in our understanding of the universe, to get closer to the underlying reality of the universe. Scientific ideas must be repeatable. They must predict future results. And they must explain things that have been observed or the results of experiments that have been conducted. Now, Bio 100 is about science, but it's also about science literacy. Science literacy, understanding science and being able to think critically about it. As Neil deGrasse Tyson said, that empowers you to know when someone else is full of shit. It helps you figure out when someone is trying to sell you the modern day equivalent of snake oil. It helps you identify fact from fiction. And there will be times in your life where you have to make important decisions that involve biology, that involve medicine. This class is designed to help you best determine if the information you have is good information, or how to find good information to help you make the best decision. So how do we become scientifically literate? Well, a lot of it is practice. We're going to do a lot of that this semester. But there are some major important categories that we need to think about. First off, correlation does not equal causation. The rate of autism has gone up in recent decades. So has the rate of sales of organic food. And the amount of natural habitat has declined dramatically. Do any of these cause the others, or are they just happening at the same time? It's very easy to assume that two things that change at the same time, one of them has to be causing the other. It's not true. They could just be caused by the same thing, or it could just be random coincidence. Relative risk is not the same as absolute risk. Something that has an 80% higher risk does not have an 80% total risk. If your original risk was 10%, raising it to an 80% higher risk brings the risk up to 18%. If your original risk was 1%, it's still less than 2%. To put it another way, your risk of dying by vending machine accident is 7 times higher than your risk of dying by shark. Does that mean you're likely to die of a vending machine accident? No. On average, 4 Americans die in vending machine accidents every year. Sharks? Yeah, about 1 every 2 years. Sample size matters. If you've got a small number of people in a clinical trial looking at a treatment for a condition. If you don't have enough people, you may not be able to tease out the signal from the noise. Things that may appear to be significant could just be coincidental. You bump into 5 people in public, and 3 of them are all named Steve. That doesn't mean anything important about the universe. It's just kind of coincidence. Same thing in scientific experiments. Studies in animals do not give you the same results in studies involving humans. This is very, very important in nutrition and medicine. We see a lot of people who read a study that was done in mice and try and expand that to humans. It doesn't always work that way. The Food and Drug Administration requires drugs to be tested in human volunteers for safety and efficacy. The FDA is considered one of the best federal agencies that regulates drugs in the world. Even so, sometimes drugs that are approved show harmful effects after approval, which is a great example of size mattering. If something only happens 1 out of 10,000 cases, it's not going to show up in a standard clinical trial that has maybe 5,000 people. But once you get 1 million people all taking that medication, it will show up. This can result in new warnings or in drugs being pulled from the market. Now, very important to realize, the FDA doesn't approve herbal remedies, nutritional supplements. So you'll see a lot of ads for things that say at the very bottom of the ad in very fine print, this statement has not been approved by the FDA or something along those lines. So it may not be, well, the truth. Something that is new may or may not be effective. Just because it's new doesn't mean it's effective. Reality is not a popularity contest. Something can be popular and not be true. The intermittent fasting diet has a very, very high failure rate. Most people cannot stick with it. In fact, dieting in general doesn't usually result in long-term weight loss, even though everybody's dieting. Ancient secrets may also not be effective. If it's something really old that's not mainstream, there's probably a reason for that. Now, some things that have been around for a long time do work. Chewing on willow bark? Yeah, great. That reduces pain. But guess what? You can buy this, the active chemical ingredient in willow bark, at your drugstore. It's called aspirin, and it's a very mainstream treatment. Testimonials, very convincing. If I go, hey, this worked for me, you should try it. That's not evidence that it works. That's just me saying it worked for me. We're different people. We also have to think about the fact that scientists are people. Scientists can have conflicts of interest and biases. Conflict of interest occurs when somebody is making a profit off of selling something. If I'm trying to sell something, I'm going to hype up that product because I want to make money. That doesn't necessarily mean that it's the best product. People also try and push their philosophies and opinions on other people. That doesn't necessarily mean that that's the truth. They might be exaggerating. And everyone has internal, often unconscious biases. We scientists are human. All humans have these internal biases. It can be very easy to make mistakes when you want something to be true. And the last point, you have to consider the balance of the evidence. Evidence supporting the idea, evidence opposing the idea. And the more evidence you have that something is true, the more likely it is that it is true. So, how do you know if something is accurate? You're not scientists. It can be very difficult for the layperson to know, is that source of information that I have seen in the popular press accurate? It can be really tricky to do. If you look at the pyramid on the left, if you saw something on the news, are you going to know what category it fits in? Probably not. You might. It might say it's an animal trial or a case-controlled study or randomized controlled clinical trial. That helps. But chances are you're not going to know that. And some press agencies are better at reporting accurate scientific information than others. So look for multiple sources saying the same thing. And look for warning signs, like endorsing a specific product, inserting a lot of hype into the report, and claiming that something is broadly and universally true. Not every human on the planet has the exact same nutritional needs. Not everyone has the same cancer risks, for example. And speaking of examples, based on what you see on the news, what do you think is the leading cause of death in the U.S.? And the next thing I want to mention is something called Occam's razor, which means if there are multiple possible explanations for a phenomenon, the simplest one is likely to be the truth. This past week, the Pentagon came out and a bunch of people went on 60 Minutes and said UFOs are real. Well, okay. UFOs, unidentified flying objects. Yeah, there are a lot of UFOs out there. A lot of them are bugs. I can't identify them. I see them fly by all the time. So if we look at this still image at the center of the screen here, this is taken from a 60 Minutes segment from a video. And the guy, the military person who was on 60 Minutes, claimed that it was an alien spacecraft. So let's think about this. If it's an alien spacecraft, that means there must be technologically advanced life out there. And they must visit us. And despite the fact that they can travel between star systems, they can't avoid being seen by us. Although they do seem to be able to make it so that cameras cannot focus, because there is not one in-focus image that isn't a scam. Now, on the other side of the coin, this could be a bug on the camera lens. Well, we have to believe in bugs. You know, I kind of do. I've seen them. We must think that sometimes bugs land on the camera lens. Well, yeah, I, I can believe that one. We have to think that cameras cannot focus on something on their lens. Well, yeah, that's my experience. And there are lots and lots of out of focus bug pictures where the bug has landed on the camera lens. And they're usually deleted by wildlife photographers. If you have an extreme idea, you have to have extreme proof for that idea. Even though we might want to believe that aliens have visited us or are visiting us, that doesn't make it true. If you find that your personal opinion disagrees with expert consensus, do you think the person who has spent years or decades of their life studying something is more likely to be true than something you saw on YouTube? Excluding my lectures, of course. And of course, not everything you see on the internet is true. This is the same snake in each picture, using a technique called forced perspective to make it look bigger than it really is.